This video speaks to the electric system for the building. It describes how electricity is transferred to a building from source to substation and to the building for distribution. Electrical supply from source. Electric power transmission, also referred to as high voltage electric transmission, is the transfer of electric power from hydroelectric, nuclear, or coal-fired sources. There's also some transfer of low voltage power from wind, geothermal, and other renewable energies to substations. High voltage transmission networks are known as power grids, or the grid. North America has three major grids: the Western Interconnect, the Eastern Interconnect, and the Electric Reliability Council of Texas. Power transmission, for the most part, uses three-phase alternating current, and the electricity is transmitted at very high voltage of 110 kilovolts and greater, which reduces the energy lost in transmission. Power is for the most part transmitted using overhead power lines, although sometimes underground power transmission is used. The underground transmission is more costly and has technical operations, but is sometimes required for specific purposes. To explain electrical storage. Since it is very difficult to store electricity, it is of great importance that supply and demand exist in a balanced state. If the grid becomes too unbalanced, it can result in catastrophic shutdown of generating sources. Due to this consideration, many major into redundant networks which can distribute the load in case of emergency. As stated, most power generation is three-phase, but there is a separate from source single-phase AC used for railway electric systems and when power is required to transmit at very long distances, usually greater than 400 miles, requires that single-phase transmission be used. Electric supply to substation. Electricity distribution to the substation occurs before the electricity is delivered to the end users or facilities of all kinds. This electricity is considered as medium voltage systems, which is 50 kilovolt lines or lower, transmitted to power lines, electrical substations, pole-mounted transformers, low voltage wiring, less than 1 kilovolt, and to electrical meters. Electric supply to facilities. The primary circuit is that which leaves the substation, and the secondary circuit is that which the customer uses. The primary circuit is three-phase, which is provided with a ground, which protects people and equipment if there is an electric short. The amperage is literally directed to the ground where it is absorbed and dissipated. Distribution voltages vary depending on the customer's need. Delivered voltage is usually obtained using stock transformers, and either the voltage difference between phase and neutral or the voltage difference from phase to phase. There are two kinds of three-phase power available, Y or delta. In North and South America, the Y power is usually used and be recognized when the power line has 4 wires and one is insulated. Also in North and South America, it is common that a single-phase 220 volt or 230 volt residential and light industrial services provided. In our homes, the 220 single phase is used for dryers and stoves. There are few substations per area which supply the 220 volt or 230 volt power as a hot wire, and neutral is connected to the building from one phase of the three-phase power source. The house voltages are provided by neighborhood transformers that lower the voltage of a phase of the distributed three-phase. The neutral is directly connected to the three-phase neutral. Socket voltages are only 120 volts, but 240 volt is available for heavy appliances because the two phases oppose each other. Virtually all power in North America is supplied at 60 Hz frequency. Outside of North America, 50 Hz is used as it is associated with 230 volt wall mounted sockets. This is the reason that electronic devices designed for North America cannot be used elsewhere in the world or they will be damaged. That is the end. Thank you.